Welcome to Make, a course taught at the University of South Florida. This tutorial discusses driving 4-digit 7-segment displays with the Arduino. We will learn how to connect the display to the Arduino, how to address the display, and we will learn how to use strobing or multiplexing for using all 4 digits at the same time. This slide shows the pin-out of a 4-digit 7-segment LED display. The 4-digit 7-segment LED display that we will use in this tutorial is a so-called common cathode display. So this means that each of the digits is all the LEDs are connected in parallel on the cathode side. Such displays are also available as common cathode displays. Then the LEDs would point in the other direction. The only thing that would need to be changed for a circuit is the polarity with which the LEDs would be driven. So here for this display from the Arduino kit, we will have to apply the positive voltage to the segment lines and the negative voltage or ground to the digit lines. So first we need to learn some nomenclature. Here we have one of the digits, and you see that each of the segments is labeled with a letter. And down here we have the decimal point, dp. So we have in total 8 LEDs per digit of this display. Now if you look at the pins of the display, we only have 12 pins, but we have 4 times 8 is 32 LEDs. The circuit up here shows how we can address all 32 LEDs with only 12 pins. You see here the LEDs for each of the digits. Corresponding LEDs of each digit are connected in parallel on the anode side. In each digit, however, all LEDs of that digit on the cathode side are connected in parallel. That allows us on this end here to select a certain segment, and on this end a certain digit. So you see, if we define a number, or all the segments that we need to make a number on one digit, by connecting the collective cathodes just for one of the digits, we can make only this one digit light up while the other 3 are dark. So if you wanted to see 4 digits with different numbers at the same time, this means you have to address them in sequence. So first this one, then this one, then this one, then this one, and if you do this fast enough, then the impression is created for the person that looks at this display that all 4 digits are on at the same time. So if you do this fast, you can set these segment lines for one digit, then change them for the next digit, and simply in the same time connect the cathode of the appropriate digit. So this process is called strobing, or also multiplexing. So when we build the circuit with this display, we have to assign Arduino pins to the pins of this display, and this is shown here in this diagram too. Here we have the Arduino pins that we will use. So Arduino pin 2 will be connected to display pin 11, so that would be this one. Arduino pin 3 to 7, and so on. Up here, these are the Arduino pins that we will use to connect to the common cathodes. One more thing before we look at the fritzing diagram. Since these are just red LEDs, of course we have to, or we should at least, put a resistor in each of those address lines for the segments, so we can limit the current. Here we see the fritzing diagram. That is basically exactly the circuit that we just saw. All the pins are connected like on the previous diagram. The 4 black lines, they connect to the cathodes, and the red lines connect to the anodes. Here are the resistors that are in the segment address lines. If you count them, you only see 7. That means that we did not connect the decimal point. So in the tutorial here we will simply show integer numbers, and if you wanted to display floating point numbers, then you would have to add an address line for the decimal point segment. That could be done, for example, by using pin 9 here that is left open in this diagram. This here shows the circuit on the breadboard. Here you see the resistors, and these are the address lines. The Arduino sketch simply runs a counter, so when we look at it while it's running, it will simply count up. And here we see how the address lines are connected to the Arduino digital pins. This is the Arduino sketch that was used. So here we start out with a bunch of define statements, and what we do here is we assign to each of the digit segments A, B, C, D, E, F, G, and the decimal point, we assign the corresponding pin number of the Arduino. So segment A will be driven by 2, B by 3, and so on. The same we do here for the common cathodes. So CC1, common cathode 1 to 4, and we drive those with pins 10, 11, 12, and 13. Here, just to refresh your memory, are the how the segments are defined. In our tutorial here, the digital point is not being used, so it's not shown here. Okay, now here comes something new. Here we define an array, and it's called number segments. And so if you have a 7-segment display, then each number from 0 to 9 has different segments that need to light up in order to make that number. So if you had a 0, for example, you would only have A, B, C, D, E, F on, but G would be off. And so this is what we do here. So the first line, that is the that defines the state of the segments for a 0. And so this corresponds to A, B, C, D, E, F, G, and the decimal point. And so as I just said, for the 0 we have to turn on all segments except the G segment, which is this one. So we have a 0, and so we go on now here and do this for all the other numbers. So if you look at this is 1, so only segments B and C would be on for 1, and this is obvious that this would show a 1. And so it goes on until we arrive down here at 9. Note that you have the backslash here between the wavy parentheses sections for each of the numbers. So this defines an array. Now remember, define is only a pre-compiling statement, and when the code is compiled, every time we find number segments, then the compiler simply inserts this text and then compiles it. And so this is what we use down here. Here actually now we define a byte array that is really being used by the sketch. So here we assign memory basically, and we fill it with these numbers. Okay, let's go to the Arduino reference and see what they have to say about arrays. So an array you can just think of as a bunch of variables grouped together, and you can address these variables with an index. And so this is what we see here. For example, here what they define is an array called mySenseVals, and this array has six individual integer numbers. And so they define here 5 of them: 2, 4, -8, 3, and 2. So you could address now the contents of this array by simply saying mySenseVals and then put in here 3, and that would then yield -8. So with this index you can scan through the numbers that are in the array. That has the great advantage over using individual variables, because now we can just use this index and with a for loop, for example, address all the content that is inside the array. Now such arrays, they can also have more than one dimensions, and what we're using in the Arduino sketch is an array with 2 dimensions. So we have essentially rows and columns, and you can think of this like a matrix. Then we have 2 indices, and with these 2 indices we can pick an element in a particular row and a particular column. So let's go back to the Arduino sketch. So this is what we do here, right? We have rows and we have columns, and these rows and columns are written into the numbers array. So we have 10 rows and 8 columns. So each of the 10 rows contains the settings for the segments for a particular number. The next array that we define, it's called segments, and here in this array we assign to each of the array elements the pin number that drives that particular segment. This here is a constant array, because this is something that we don't want to change, as long as we would really physically change the hardware. This is a way to prevent that accidentally in the code a variable is changed if you don't want that to happen. We could actually have put a constant here too, because of course these segments are also something that doesn't change. Okay, so we go on here to the setup function. We start out with a serial begin. This is just used in this sketch, or I use that for doing some debugging because it didn't work in the beginning. So it's still in here. And then we define the modes of the Arduino pins that we're using. And since we are driving something and not reading an input, they are all set to output. So we'll go here through the pins for the anodes and set them to output, and at the same time we use digital write to set these outputs to low, so they have 0 volts. So the anodes are all at 0 volts, and then we do the same with the common cathodes. So we have common cathode 1, 2, 3, and 4, and also we set them to output, and we give them a high setting, so they are all at 5 volts. So that just means that the LEDs are all biased in reverse right now, and so that means they are off. No light is coming out of them. Okay, down here, this is the main loop of the Arduino sketch, and here we just have a simple counter that consists of 4 for loops that each count from 0 to 9, and they are nested within each other. So this one here counts the fastest, then this one goes a little slower, this one goes even slower, and this here is the slowest. So this here is the lowest power of 10, then 10 to the 1, 10 to the 2, 10 to the 3 in the decimal number scheme. This most inner for loop that counts just t from 0 to 19. This loop now strobes the digits of the 4-digit display. So we use the function setSegments, and here we set the segments for digit 1, for digit 2, for digit 3, for digit 4. So the definition of setSegments, this function we find here in functions. Okay, let's have a look at the setSegments function. So the setSegments function has three parameters. The first one is the number that we want to show. The second one is the number of the digits the number should appear on, and time that defines how long we turn on the segments. Okay, so in this for loop, we count the segments from 0 to 7. And in this if statement here, then we look up in the numbers array for that particular number that we specified here, which segments are to be turned on, which segments are 1 in this array. And then if there is a 1, if we find a 1 in the array for that particular segment, we use digital write, look up the pin number for the particular segments and set it to high. So that puts 5 volts to the anode of this particular segment. If we find a 0, then the else statement is executed, and so we use digital write for that particular segment and set it to low. So that puts 0 to the anode, and that means the LED cannot be on. After we set all the anodes here in the for loop, then we turn on the common cathode. So that means we set it to low, right? Because we're 5 volts on the anode, we need 0 on the cathode in order to turn the LEDs on. And that, since it's a common cathode, we just need this one digital write that sets the cathode for that particular digit that we call the function for to low. Now, then we wait, and this is a new command. We use here delay microseconds. So instead of the standard delay function that uses milliseconds, we have a delay microseconds function where we can specify the time in microseconds. So the time that we send here, this number is microseconds. That's the sets microseconds that the segments are on. After the time is over, then we use another digital write and we set the common cathode to high, and that turns all the segments off because we have now 5 volts on both the cathode and the anode. And then we jump back at the end of this function back into the main loop. And so after we flash one digit, then we do the same for the second one and for the third one and the fourth one. So there's always one digit on and the other 3 are off. You may have noticed that the sketch changed slightly. I put in here on time instead of the 100 microseconds that we had here before. I decided it would be better to use a define statement for that on time. And also it turns out that instead of 100 with 3000 we get much brighter LEDs. So you can actually use this on time to adjust the brightness of the LEDs. So anyway, by using the define statement, we only have to define the on time once up here, and then in all these 4 function calls down here it is updated automatically. So it's always good to use for constants define statement instead of putting the constants directly into the code. Now you know how to operate a 4-digit 7-segment display with the Arduino. Now it's time for the in-class project. And in this project, you will write a class to operate such a 4-digit 7-segment display. Writing classes was discussed in the previous tutorial, so you should have watched this. This would make it much easier to do this in-class project. The methods of this class, so the functions that should be implemented, they should, of course, the first one should be the constructor. Remember, the constructor allows us to pass some properties into an object when we instantiate it. And so in this case, of course, since we have so many pins to connect, we define in the constructor which pins are being used for the segments and for the common cathodes. Okay, then the methods to operate the display. Probably the most important one is just a simple set value. So you could pass a number to the display and it would then show that number. Every time you set some property in an object, it is good to also write a method with which you can get that property. Right, so you could set the display to some number, and then in some other part of your code you could actually ask the display what number are you displaying right now. That might be useful. Okay, then since such a display, no matter whether it shows 0 or 1 or 2 or 9, it always has some LEDs on. It may be useful to have a method with which you can actually turn all the segments off. So this would be turn display off. And then, not so important, but might be useful, you could write methods that would count up the display or count down. So this would help with the implementation of a simple counter. So once you have these methods and the constructor, the class is defined, then you can start experimenting and use these methods. So you could add some more buttons to reset the display. You could do that with the set value, right? So that the counter, for example, would set to 0. You could use the count down and count up with 2 buttons. And of course, you could have a button that turns the display off. This concludes our tutorial using a 4-digit 7-segment display with the Arduino. Thanks for watching.